Welcome to The Explainer. Today, we're diving deep into one of our planet's most powerful and, well, predictable rhythms, the constant rise and fall of our oceans. It's like a planetary heartbeat you can see on every single coastline.
You know, if you've ever spent a day at the beach, you've seen this happen. You set up your towel, think you're a safe distance from the water, and then a few hours later, the waves are right at your feet. So what's really going on here? What's behind this massive, global-scale phenomenon?
Well, to really get to the bottom of it, let's start with a solid definition. Tides aren't random at all. In fact, they're this incredibly regular, rhythmic movement of the oceans, a kind of planetary pulse that's driven by forces way out in space. Okay, so let's zoom out, way out. Forget the shoreline for a second, and let's look at the cosmic forces at play here. Because this isn't just about water. It's really a gravitational dance, a tug-of-war, really, between the Earth, the Moon, and the Sun. The main character in this whole story is for sure the Moon. Now, you might think the Sun, being so huge, would be the bigger influence. But the Moon is so much closer to us that its gravitational pull is actually the single biggest reason we have tides on our planet. Now, here's where it gets a little weird, a little counterintuitive. The Moon's gravity actually creates two high tide bulges at the same time. The first one makes total sense. The ocean on the side of Earth, facing the Moon, gets pulled towards it. Easy enough. But the bulge on the opposite side? That one happens because the Moon is also pulling on the solid Earth itself, pulling it away from the water on the far side. So that water gets kind of left behind, creating a second bulge.
Of course, the Sun definitely gets in on the action too. I mean, its gravity is massive, but because it's so incredibly far away, its effect on our tides is actually less than half that of the Moon. So you can think of the Sun as this secondary force that either helps the Moon out or kind of works against it.
So here's the key to understanding the daily cycle. Those two tidal bulges, they're more or less stationary, held in place by the Moon. It's our planet that's spinning on its axis. As your spot on Earth rotates through that first bulge, you get a high tide. Then about 12 hours and 25 minutes later, you pass through the second bulge and, you guessed it, another high tide. That's why most coastlines get two high tides and two low tides every single day.
All right, so we've got the cosmic forces all figured out, but the story doesn't end there, not by a long shot. Once all that tidal energy gets to our planet, Earth's own geography, its continents and oceans, steps in and really shapes what the tides look like from the shore. You know, the shape of a coastline, how deep the ocean floor is, even the local weather, all of these things can totally change the tidal patterns. A wide-open coast might have a really small difference between high and low tide, but a narrow V-shaped bay can have a massive, massive difference.
And this is a perfect example of that in action. The Bay of Fundy in Canada, it's world famous for having the highest tides on Earth. And why is that? Well, its unique funnel shape basically squeezes all that incoming tidal water into a smaller and smaller space. The water has nowhere to go but up, and it rises dramatically, sometimes over 50 feet. It's a wild example of how geography can amplify these cosmic forces.
Okay, so let's look at the biggest tidal variations we see over the course of a month. It all comes down to a very specific alignment, how the Sun, the Moon, and the Earth are all lined up in space.
So, a couple of times a month, during a new moon or a full moon, the Earth, Moon, and Sun are all in a straight line. When that happens, the Sun's gravity and the Moon's gravity are pulling together. They're working as a team. This creates what we call spring tides. And no, it has nothing to do with the season. It just means you're going to see the highest of high tides and the lowest of low tides.
But what happens when they're not working together? During a first or last quarter moon, the Sun and the Moon form a 90-degree angle with us here on Earth. So their gravitational forces are pulling in totally different directions, which means they partly cancel each other out. This gives us neap tides, which are way more moderate, with the smallest difference between high and low tide.
So, let's just break that down real quick. Spring tides are basically tides of addition. The forces combine and you get a maximum effect. Neap tides are tides of subtraction. The forces work against each other and you get a minimum effect. And you can watch this whole cycle play out, like clockwork, twice every month.
Okay, so this whole cosmic dance thing is super fascinating, right? But what does it actually mean for us down here on Earth? Well, it turns out this rhythm is absolutely fundamental to life and our planet's systems.
I mean, tides are a vital engine for our planet. They literally carve out landscapes. They create these unique intertidal zones where countless species feed and breed. And they act like a giant circulatory system for the ocean, mixing the water to spread heat and nutrients all around the globe. In fact, fun little tidbit, the friction from all this water moving around is actually slowing down Earth's rotation, making our days just a tiny fraction of a second longer every century.
So let's bring this right back home. Let's get practical. Why should this predictable cycle matter to you, especially if you don't even live near the coast?
Well, the answer is they're deeply woven into our economy and even our safety. Ship captains use high tides to get into shallow ports. Fishermen follow the tides to find fish. We build seawalls based on tidal predictions. And knowing the tides is absolutely critical for predicting how bad a storm surge might be. We can even harness their incredible power for clean energy. And that kind of leaves us with one final, really crucial thought. For thousands of years, we have relied on the predictability of the tides. But as our planet changes, as sea levels continue to rise, this ancient, reliable cycle is going to interact with a new, much more uncertain future. So how will higher sea levels affect these cosmic rhythms that we depend on? Honestly, that's a question we're all being forced to answer right now.